Anyway, どうしようかな。Can you flip these two screens? Presentation and my face? No? Can you hear me? うわ
He's asking whether the main one is his presentation.
Hi, Professor Kasahara. Can you still
Yeah.
hear us?
Yes, yes.
Right, we can hear you. Right,
Thank you.
right.
Uh,
And right now we can see the screen showing the first page, security workgroup session, right?
yes, yes.
Right.
So, may I start?
Sure, yeah.
Okay. So thank you very much for coming to this security working group session in APAN 56 in Sri Lanka, Colombo, Sri Lanka. I'm chair of APAN Security Working Group, Yoshiaki Kasahara from Kyushu University, Japan. And there are also another co-chair from remote, Dr. Rakesh Jha-san from India. And also there is local, physically, Mr. Jamie Gillespie from APNIC is here, but I'm not sure if he's in that room or not. I'm sorry. And I'm sorry to keep you waiting. This is the first time I tried to chair the session remotely. I'm sorry to say that I cannot attend APAN meeting this time physically due to my some problems in my side. But anyway, I'd like to start the session. I expect local presenter is already here. I can't check that. So there will be 5 presentations we gathered. We will have 3 presentations in the first session from 9 a.m. to 10:30 a.m. And then one break and then 2 presentations afterward. So, Shankar-san, are you here now? Could you please prepare for your presentation? The first presentation, the P2P botnet threat mitigation life cycle. I wanted to give presenter about 30 minutes, including question and answer. So I stop sharing my screen and
Okay, thank you, Kasa.
anyone please change the screen.
Can you switch to the presentation?
Okay, please go ahead.
Okay. All right. Thank you, the chair of the working group. So allow me to actually present my topic today. It's going to be called the Peer-to-Peer Botnet Threat Mitigation Lifecycle. And my name is Shankar Karupaya. You can just call me Shankar. I'm a senior lecturer from University Science Malaysia. So I did my PhD from TU Darmstadt, and my topic was advanced monitoring of peer-to-peer botnet. So this is more of an extension of what we did. And my current research interest is on cybersecurity, malware, and botnet monitoring. I also have a special interest on distributed systems and IoT. So without further ado, let me just go on a bit of background on malware. So malware is something that has started back in the 1980s itself. So malware stands for malicious software. In the 1980s, it was just for fun. The main goal was to trick people, or rather to make fun of people. So that was the inception. And the motivation at the point was just fun, right? So you can show people, you can tell people that I can do this and so on. But moving forward around early 1990s onwards, we started seeing exploitation and evasion techniques being incorporated in malware. At this point, you don't require user intervention anymore. So they behave or they react by themselves, like worm propagation and so on. And at this point, we started seeing malware that starts having curiosity. So can I actually install a backdoor? Can I erase the hard drive? So these are the things that they have been focusing on in the 1990s. Now, 2000 onwards, you started seeing elements of social engineering being included in malware. And we started seeing a lot of competition among malware authors. So they want to see who can have the bigger market of the cybercrime and so on. Example of malware at that point was Storm, Slammer. You might have heard about this in the past. Now, at this point, you already started seeing finance-oriented or financially driven malware authors or attacks and so on. Now, 2000 onwards, we started seeing increased sophistication. We started seeing state-sponsored actors. We started seeing ransomware emerging and so on. Of course, here we have more towards the financial motivation. We started seeing data exfiltration. So when I say state-sponsored, you see organizations trying to siphon out information from your organization, especially governmental organizations and so on. So in 2020 onwards, we are looking at next generation botnets. So quite a number of them. So I'm not going to detail them, but I'm just going to summarize on what are botnets. Basically, I mentioned about malware. So if you have a malware and you have a remote control mechanism or C2 mechanism, and you have an actor or threat actor, in this case, we will refer to them as botmaster, then you have what we call as a botnet. So what are botnets? The proper definition that I would give is pretty much malware infected machines that are connected over the internet, that are being controlled by a botmaster to carry out illegal activities such as DDoS attacks and so on. I think Jamie mentioned yesterday that there has been a case. In fact, on Google in 2017, there was a 2.54 terabits per second. In fact, more recently, we have 3-point-something terabits per second. Regular organizations will not be able to withstand such an attack. But all these attacks are originated from infected machines alone. So they don't have to generate the traffic by themselves, but they are making use of the infected machines. And you also have attacks such as pay-per-click exploitation. So you have 1 million infected machines. They will ask these machines to visit a particular ad that is placed on a particular website. And then organizations like Google will actually give money for a number of clicks. So back then, there was a botnet called Zero Access that was reported to actually be able to generate $100,000 a day just using 1 million infected machines. So this was the real case in 2012. But of course, Google have since improved the algorithm. They are able to distinguish between artificial and also natural clicks. Traditionally, you have centralized architecture botnets. Pretty much imagine you have a web server, you set up a C2 there, you infect some machines, ask them to communicate to this C2 server. So that's the centralized architecture. It's very easy to set this up. The botmaster will just have to pass the commands to the botnet through the command control server, and everyone else will get the information. Like, okay, launch DDoS on this machine at this time and so on. However, such an architecture serves itself as a single point of failure or a single point of monitoring. So imagine I have access to the visitor logs. I will immediately know what are the IPs of these machines that has been accessing the C2 server. Now, realizing that this is a weakness, a lot of recent botnets have migrated from relying on centralized architecture, but instead they're using peer-to-peer architecture, whereby you do not have any centralized servers anymore. Instead, the bots will actually communicate among themselves, right? Each bot will know a subset of other bots, and through that process, they remain connected. And in a peer-to-peer botnet, a bot master can issue a command to any bot that he wants. So there's no one single location. And this information will be disseminated in a hop-to-hop fashion throughout the botnet. It's a bit slow, but it works for the process they want. Now, again, a bit more on how this unstructured peer-to-peer botnets would look like or operate. So imagine that you have a D. Each bot here would have something that they call membership maintenance mechanism. This is the mechanism that ensures that everyone remains connected. If they're disconnected, they will not be able to communicate to other nodes. So they have a neighbor list. You can imagine that as a phone book. You know how to call your friend. So here, each bot will know how to communicate to another bot. So they remember a subset of others. Let's take the example of node D here. Node D, sorry. In reality, we have bots that have between 50 to 1,000 entries. In this example, I'm just going to give 3. We also have 2 classes of bots. The first one is super peer, meaning you can reach them using public IP addresses. They are not behind NAT, they're not behind private IP addresses. And this is a class of bots that will appear in the neighbor list. Imagine node D here in the middle, right? Node D is connected to E, F, and G, or rather knows E, F, and G. Therefore, the neighbor list of D will actually look like this. So, of course, it won't be just E, F, and G. It will be IP address, port combination, minimally. So part of the mechanism is to ensure that every neighbor is actually alive. So if you know how peer-to-peer architecture or peer-to-peer communication works, you need to send heartbeat messages to check whether the other person is there or not. And as such, you will send a so-called hello message from time to time. And depending on the response, you will know who's actually offline and who's not. So in this case, G didn't reply. Maybe it went offline, or maybe it was uninstalled. Now D will assume G is offline. And there is a mechanism where you can replace G with new nodes, which is to ask one of your existing nodes. In this case, could be F. Hey, F, do you have someone that I can ask for my neighbor? I mean, do you have someone else that I can consider as my neighbor? F might say, sure, why not consider I? I has been responsive. With that information, D will now remove G from the neighbor list and replace it with I. So that's why peer-to-peer architecture or peer-to-peer botnets are super cool, because they are self-organizing, self-healing, and so many self-properties that they have, right? So a bot master only needs to set it up once, and then he doesn't have to worry about it anymore. Now, the second class of bots within the peer-to-peer botnets are non-super peers. These are class of bots that are behind firewall and NAT devices, whereby super peers cannot communicate to them directly, but these guys can actually communicate to super peers. That's why in the neighbor list, you will only see super peer IP addresses. You won't see the non-super peers because they won't be there at all. So with that, that's the background on peer-to-peer botnets. So now I'm going to share about what we are doing at University Science Malaysia, the entire life cycle. And maybe you can see where you are doing work that is relevant to this life cycle. At the very beginning, inception stage, a malware author, maybe Mark, right? So he might actually come up with a malware, release it in the wild. I wouldn't know. I'm a researcher. It'll take some time before I'm able to detect them. That's the phase 1, which is detection phase. You can only detect emerging bots by using a combination of tools, such as honeypots. You can deploy honeypots. You can have IDS-based detection mechanisms, maybe anomaly-based. Signature-based is probably after you know the malware exists, right? And sometimes you see suspicious files, you execute it in a sandbox, and then you realize, okay, this is something malicious. So these are some of the techniques that you will use in order to identify them or detect them in the first place. So there are also other kinds of malware sandboxes. Online one is VirusTotal. If you never heard about it, just go virustotal.com, upload any malicious file or any file, and then it will tell you whether it's malicious or not. Okay, so once I know, okay, this is a malicious file, what can I do next? Next is the interesting part, which is called reverse engineering. Reverse engineering is conducted using a lot of tools, and some of them would be IDA Pro and Ghidra. IDA Pro is, you have the paid version, you have the community version. Ghidra is open source, so you can actually work with it. Reverse engineering is aimed at understanding the communication protocols of the bots. So how do they speak? Normally, they don't speak on regular protocols. They use custom protocol, custom encryptions, and so on. Reverse engineering tries to understand or reconstruct this protocol, as well as extracting the seed list or the bootstrap list, the neighbor list I mentioned earlier. Now, the whole process is critical, but it's a very time-consuming activity. We lose a lot of visibility at this point. That's why the red line here indicates I do not have visibility of the botnet until I complete my reverse engineering when it becomes yellow. So what's the yellow? That's the phase 2, where I conduct monitoring. The objective of monitoring is to enumerate the infected machines. Basically, I want to know what are the IP addresses of the infected machines throughout the globe, right? So different networks, I'll get this information. With that information, I can alert the stakeholders, the network administrators. I can inform them this IP address has been infected because it was communicating using this botnet protocol at this time. So using their internal logs, they can identify and probably work on cleaning those machines. Ideally, we'd also like to identify control infrastructure. So if they are all deploying or dumping their stolen credit card details on a certain location, you can take it down so they cannot do it. But of course, the super difficult, but the most ideal thing is to identify who's the person behind the botnet itself. So identifying the bot master or bot master attribution. Now, there are two common monitoring mechanisms. The first one is called crawlers. Crawlers is, and the second one is called sensors. So crawlers is pretty much an application that we, as a researcher, will develop. Can be Python, whatever language, because we will communicate using network protocols. And the goal is to identify what are the infected machines and how are they interconnected. For that, we have to develop the crawler by understanding the protocol. You already reverse engineer, and you know the seed list. So knowing seed list means you know at least one node in the internet that is already infected. We only need one. Remember when I said you can ask for neighbors from your other neighbors? By exploiting that particular message, we will send a crafted message to this node. A will think that this is just another infected machine and say, you don't have enough information, you don't have enough neighbors. Why not consider mine? I know B, C, and D. When I receive this information, the crawler at the back end will start reconstructing the topology. I know A is connected to B, C, and D. Then I choose another node. In this case, could be D. It could be any. We will do an exhaustive search anyway. After some time, after you iteratively ask each and every one of them, you will be able to reconstruct everything you see at the top, at the bottom, behind, right? So you will be able to know IP addresses of machines and so on. So we will reconstruct this as a graph and then do further analysis. But the issue is, through crawling, you only discover 10 to 30% of the entire bot. 60 to 90% is actually behind NAT and firewall. You cannot discover them through crawling. So what do we have? Oh, sorry, before I go there, this is the visual representation of the Game Over Zeus botnet, very famous botnet. This is how they're interconnected. If you can see the middle ball, the blue ball, those are actually very highly stable infected machines that have themselves as neighbors. And everyone that is outside, they are actually unstable nodes, right? So it's very difficult to take this down, but this has been taken down as well. Moving forward, to address the drawback of crawlers, whereby we don't have visibility on non-super pairs, we have sensors. We will also develop sensors or design it in such a way we understand the protocol of, remember the heartbeat message I mentioned earlier? When I say hello, I'm expecting a reply. That's the only thing that this sensor will need to know. I'm going to skip how the sensor is being deployed in the network. I'm going to skip that part first, but for now, just assume D, F, and G has information about S in their neighbor list, right? The sensor will just have to read. And anytime someone says hello to you, you just respond back to them. Eventually, you will have nodes that are not already having our sensor asking to these nodes. So C might be asking D, hey, do you know any neighbors that are stable? D will eventually say, you know what, consider S. S has been stable for quite some time. Now I'll start saying incoming connection from C. Now, if you wait even longer, nodes that are behind NAT and firewall, which is the non-super pairs, will also start asking other super pairs, hey, do you have any neighbors that I can consider? At this point, when the non-super pairs communicate to me, I am able to identify them just by looking at the IP addresses. I know that this is an infected machine that is behind NAT. If I wait even longer, eventually I will see incoming connection from all the nodes, with the condition that my sensor will never go offline, meaning I have a very stable connection and I never take down my sensor from the internet. The drawback of sensors is that you only know who they are, you don't know how are they connected among them. That's actually a big issue. So in reality, we do a combination of both crawling monitoring data and sensor monitoring data together in order to further analyze. Here we have the a simple plot of all Sality bots on the 1st of April 2015. So Sality is just another peer-to-peer botnet, which is a malware dropper. Now I just mentioned about phase 2, which is the monitoring phase. Moving forward is where we see the light end of the tunnel. That's phase 3, where we react upon it. The reaction phase is particularly relevant for law enforcement agencies. In Germany, we have BKA, Europol, Interpol, could be any organization that is relevant for your respective countries. And there are many ways on taking them down, but most often it requires a vulnerability in the software itself. You can only discover this during your reverse engineering process, only if you're careful. So if you're able to identify the bot master, that's the ideal thing, because if you do not detect who is he, if you don't identify who is he, no point of taking down the botnet, because it's just going to create another bot. And the second part, which we often see, is the overlay sabotaging or disruption. So remember the connection among the bots, we will disrupt it in such a way that they cannot communicate to others. There are a few techniques, poisoning, partitioning, and sinkholing, but it requires further careful planning and execution. I'm not going to go into details how this is done, but feel free to talk to me due to the lack of time. And once this is done, then you are able to disable the botnet. And as I mentioned, we have the red where you have no information, yellow is the part where you have information, and green when you have all the information. But as I said, this is a life cycle. After that, it's just waiting for another botnet, and you have to repeat the whole process again. Now, everything that I mentioned theoretically is easy and straightforward, but it's not, right? The bot master can actually own. Bot master actually knows we are doing all this, and they have defense mechanisms to prevent this from happening. So I'm just going to briefly mention some of them. And also some natural challenges, right? So the detection stage, normally it's quite slow, because botnets are not necessarily infecting all machines throughout the globe on a fair manner, right? Sometimes you have infection like Stuxnet that is only focusing on certain countries. So unless you're monitoring on those countries, you will not see this happening. And existing detection mechanisms are very tailored to a specific peer-to-peer botnet. You cannot generalize it easily to different peer-to-peer botnets. That's also another challenge. In terms of the reverse engineering part, so we don't have enough information. It's a very time-consuming information. Even if you execute on Sandbox, you only see a few. You probably know some of the bootstrap nodes. That's about it. And the anti-reverse engineering mechanisms are also implemented, like code obfuscations, a lot of things that are also implemented to prevent us from easily or using automated tools to reverse engineer. But the thing is, this is also the ideal situation where you want to identify what are the infected machines or the population. Because imagine, upon inception, if let's say I have 10 machines in the very beginning, at the beginning of my reverse engineering, maybe there's only 200 nodes out there. If I monitor these 200 nodes, I could potentially see the interaction between the bot master and the bots. But if I wait until I finish reverse engineering, probably the size is now 2,000 or 20,000, which is going to be like finding the needle in the haystack, right? So in terms of phase 2, the monitoring part of it, there are some issues in terms of being able to quickly crawl, because there is churn, so you won't get the exact view if you actually crawl slowly. So imagine that G goes offline before crawler gets to contact G. You will not discover I, and hence you will not discover J. So there are some issues like that. And if you go to the natural behavior of the internet, this is a crawl data of Sanity for 7 days in 2015. Initially, when I crawled, these are the number of infected machines or IPs that I saw. Really cool, 12,000 in 7 days. But if I look further in the details, out of the 7,000 that I saw, 12,000 that I saw, there's only about 1,004 that was responsive. The rest never responded. Why? So this is what we call as IP address aliasing, meaning the same node were appearing on different IP addresses. So a lot of funny stuffs are happening around the internet. And but if you look into the sensor data, earlier, remember, I only saw about 1,000, but if I look into the sensor data, the top part, the blue triangle, those are IPs aggregated in 24 hours. So you're looking at something between 160,000 and 260,000 nodes in a day in terms of unique IPs. And if you look at the bottom, the red one is hourly aggregation. So you still see about 30,000 to 70,000 unique IPs at any point in time, right? So we have also validated that 90% are not directly found through crawling. So we have to use both. And there are also some interesting things like, did you notice that something is actually falling down? The whole blue line is going down. That's the decay rate of the botnet. Machines getting cleaned up, the malware gets removed and stuff like that. And this 7 dots that you see here is actually the diurnal behavior of machines turned on and off throughout the globe. So on Mondays, you will see the highest peak. No, on Sundays, you will see the highest peak when we were monitoring from Germany. And by the time it's Friday and Saturday, you'll see the lowest peak. So that's why you'll see 1, 2, 3, 4, 5, 6, 7, and then peak again. So these are machines that are turned on concurrently throughout the globe, or infected machines. Right, so there are also anti-monitoring mechanisms and countermeasures that are being implemented. Like I mentioned, you have to crawl quickly, but and you don't get all the information. Botnets are only giving some of the information. Sality has an ABLIS of 1,000, where every time you ask, it gives out only 1. So you have to repeat this whole process. And to make it even worse, they are also trying to limit what kind of information given to you. So there is a botnet called Game Over Zeus that makes sure that even if you ask 1,000 times, you only get the same 10 nodes out of the 50 that it has. So there's some determinism and so on. And Game Over Zeus also have a mechanism that checks if a bot is contacting too frequently. If yes, it will blacklist you. And if you blacklist you, you won't be able to communicate to that node anymore. Right, so there are many more things there. I'm going to skip some part of it. And there are also some legal and privacy challenges. So whether GDPR is a concern when you're doing monitoring. When we were doing it from Germany, we wrote a paper and we managed to argue that it is not an issue when you just collect IP address as IP address for your monitoring as personal identifiable information. And how do you track bot masters? Because a bot master can issue commands from any node. So that's the biggest challenge that we can't do much. And we also have issues of cross-border legislation. We managed to actually work closely with law enforcement agencies with one botnet, but that's when I realized it's far more difficult than just monitoring them. Taking them down, you have to talk to legal people, you have to talk to LEAs of different countries. It's not easy to get everyone on the same page. And there's also some other issues in terms of botnet disruptions, because it's unpredictable what's happening over the internet. And sometimes you only have one chance to take them down. If you miss that chance, they will fix it and you won't be able to take the same chance again. So in conclusion, new peer-to-peer botnets will continue to emerge and evolve. As of now, it seems like a cat and mouse game. They do something, we do something. It keeps on going in this manner. But botnet monitoring is an essential activity that needs to be done both timely and carefully. And our own experience in monitoring have indicated that it's more than it meets the eye. There's so many things that we don't actually know that we are still struggling to understand. And if there are others that are interested in this topic, feel free to talk to us and we'll gladly bring you guys up to the speed. Thank you. With that, I open the floor for questions.
Thank you very much for your comprehensive and informative presentation. Any questions from the audience?
Was it too fast?
I have how can I say? I have a question. You in the last slide you called for participation or joining the activity. What kind of actual project or activities if we are interested in your activities?
Okay, some of the things that we notice is that some nodes, as I said, so if we consider the blacklisting mechanism, right, we will not know that a bot has blacklisted us. If you trip that mechanism, we will never know. But if we have different monitoring points, that means we have different organizations that are monitoring at the same time, then we can actually verify that, okay, this bot is not responding to my machine, my crawlers with this IP, but they're responding to another machine with a different IP. This is one example. And some of the defense mechanisms of botnets is that they prevent the deployment of multiple sensors by limiting a /23 or /24 subnet. So in the enable list, for every /24 subnet, you can only have one IP. But the thing is, my institution can give me a /24 subnet, for example, but I can only use one IP out of it. And unless we collaborate with different organizations that have different blocks of IP addresses or public IP addresses, we cannot do most of the things that we are doing right now. So there's very few people who are doing this throughout the globe, but we are really encouraging more people to step in, mainly because we don't have visibility from different networks. At least from a measurement point of view, that's an easier thing to get in. But there are a lot of botnets that are coming up. We cannot actually reverse engineer each and every one of them as well. So it takes time. So if you get different people looking into different things, we can help out by having our whole crawler and sensor framework. It's a framework. We just have to fit in the protocol, and then it should be able to monitor a new botnet by itself. So those are also the other aspects where others could collaborate.
Thank you very much. Rakesh-san from
Yeah.
remote.
Yeah, thank you for your nice presentations. I have there's two doubts. What are the features you have incorporated for intrusion detection system? And secondary, how on the what basis of features botnet is able to detect the what types of alarm is coming? And secondly, since sensors node have very less memory. So if there are more than flooding attack types phenomena is there, then how they can able to detect the previous already incorporated IP address and other things, because sensors nodes if they compute itself, then the battery lifetime and lifetime cycle is very low for the sensors. So could you please comment on this?
Sure. I'll take the first question. The first question on how we actually try to detect peer-to-peer botnets from an IDS perspective. So what we have worked on is to identify the periodic behavior. Earlier in this slide, or the slide where I mentioned bots will actually send out a periodic message to ask, hey, are you there? A heartbeat message. Now, this is very, how do I say, very common or very limited to peer-to-peer botnet, or rather peer-to-peer based applications. And each peer-to-peer botnet have a different signature or other different timing pattern that they have used, different packet constructions and so on. So we make a combination of this to actually detect. But the thing is, you cannot generalize across different botnets, but that's what I mentioned earlier. So I hope that answered the first part of the question. The second part of the question was about the sensor node. Now, the sensors, even though we name it sensor, it's not really the IoT-based sensors and so on. They are pretty much just infected machines. Well, we deploy a machine, normally a VM, that has the protocol implemented. That's it. We call them a sensor, but it's not an IoT-based sensor and so on. It's fully connected on the internet with power and so on. So that's
so that is some type of host and system itself. Yeah.
Yes, indeed.
Yeah.
But from the outside, it will look like any other infected machine, because they can only interact through network protocol. They won't be able to distinguish whether it's an infected machine or re-implementation of it.
So if I'm not wrong, you have detected through nature and behavior nature of the
yes.
Yeah. Thank you.
Welcome.
Thank you very much. Actually, I want to discuss about more technical detail, but I'm sorry, I didn't go to Sri Lanka this time.
Anyway, we can meet again. No worries.
Yeah. Anyway, thank you very much. I think it's time to proceed to the next presentation. So thank you very much again for your valuable presentation. So thank you very much. So next presentation is by Ikra Amin-san, same university, University of Malaysia. So could you please prepare for share your presentation from your side?
Yeah, sure, Kasara-san. Let me just present. Can you hear me properly?
Yes.
Okay, cool.
Very clear. Uh,
Can you see my screen?
it seems okay, I think. Yes.
Yeah.
So please go ahead.
Okay. Okay. So good morning, everyone. My name is Mohammad Ikrar Amin. I am a researcher doing my master's under the supervision of Dr. Shankar, the person who just presented before me. And the topic that I'm researching on is enhancing incident response in outsourced SOC solutions. And it's still a work in progress. And at the current stage, we have actually identified the issue with the incident response of the outsourced SOC solutions. And in today's presentation, I will go through what exactly is a SOC, the problem that we have identified, and what is the incident response and incident response lifecycle. And then I will conclude my presentation. So for the past few years, we have seen a rise of attacks in the globe, and especially during the COVID times, the threat actors have been targeting educational institutions, and along with that, they have also been targeting critical infrastructures. And after so after they go through all this attacks and everything, we have also seen the rise of ransomwares. Here, if you see, in Malaysia, there has been rise of 16% year after year until in 2022, and there have been data breaches almost everywhere. If you see over here, this was recently T-Mobile customers' data was hacked. And what do the organization do other than employing a firewall or IDS or IPS? Is that they deploy security operation centers. And what exactly is a security operation center? It's basically a centralized unit within an organization which is responsible for monitoring, detecting, responding to the security incidents and threats. And a SOC team as a whole are actually responsible to ensure that the confidentiality, integrity, and availability of the organization is preserved. And there are some roles and responsibilities of a SOC, which includes continuous monitoring, where a SOC team actually monitors a company's infrastructure 24/7 hours, 24 hours a week, seven days a week, and 365 days a year. And another role that they have is actually incident detection. So they analyze the data, they collect the data through different sources, they analyze it, and they deploy different tools to actually detect the incident inside of an infrastructure. And they also perform threat hunting, where they actually proactively search their whole infrastructure to look for any threats that are in the organization. And lastly, they carry out incident response, where they assign several personnel to investigate and respond to the security incidents. Now, there are actually several types of SOC models, which includes internal SOC. In internal SOC, the organization set up their own SOC team within its own workspace. So they actually are aware of the organization's infrastructure and what goes in and out of the organization. The external SOC is where a third party or a managed security service provider, MSSP, offers their SOC services to the other companies. And the third type is the virtual SOC, where the SOC teams actually work remotely and they don't have a dedicated facility. And the fourth one is the global SOC. It's basically a high-level group that oversees smaller SOCs in a region. And the last one is co-managed SOC, which is basically where the organization's IT team, it tightly works together with the outsourced SOC providers. But for the sake of this presentation, I would like to focus more on the advantages of internal and external SOC. So let's look at what are the advantages of an internal SOC. So An internal SOC has an advantage of having in-house expertise, which basically means that the people that are working inside the SOC are actually from the organization itself. So they actually knows what's happening in the organization and what services they're using. So they have the knowledge about the infrastructure of an organization. The second advantage they have is that they have direct access. So if they have the direct access to the organization's assets, it allows them to quickly respond to the threat itself. And the third one is the tailored approach. So since it's based on their own infrastructure, they can actually customize their policies to however it suits the company itself. And if you look at the external SOC has the advantage that they have some specialized expertise. So since they have worked with different kind of organizations, they can actually offer their expertise to a different type of organization. And they can also scale, they are also scalable and flexible. So they actually offer flexible solutions that scale according to organization's need. And this allows for them to actually optimize the resources that they have. And lastly, it's cost efficient, cost effective, because the resources that they're using are actually from outside. They don't have to have all the resources and all the expertise from the organization itself. So it actually costs less as compared to the internal SOC. So why do I want your focus to be on the external SOC itself is mainly because it's mostly employed by SMEs. And according to a Forbes report, SMEs are actually the most targeted sector for cyber threats. And if you see the first stat over here, there are actually 43% of the attacks that happen on SMEs. And another report suggests that there is about 3.4 million vacant cybersecurity positions globally. And inside Malaysia, we have around 27,000 cybersecurity workers needed by 2025. And the person who actually interviewed in that meeting also says that and I quote his statement, the scarcity of skilled talent is a concern for SMEs that lack resources and expertise, making them vulnerable to cyber criminals. So because of this, most of the SMEs actually target to go for outsourced solutions. And the issue with outsourced solution is that we as a outsourced provider actually ideally want a robust and efficient incident response, and that actually mitigates security incidents. And however, the limited access to the company's infrastructure, the communication or coordination issues, and restricted data access actually hinders this response time. And as a result, the organization faces data breaches, operational disruptions, financial losses, and reputational damage. So I've actually mentioned a lot of time about incident response. So let's look at what exactly is an incident response. So incident response is basically identifying, managing, and mitigating the impact of security incidents on an organization's information system. And in the process of incident response, we coordinate with our team members and try to contain the incidents. We investigate how it was caused. We try to eradicate it, and then we try to make sure that the normal operations of the organizations are maintained. And this is the incident response lifecycle, which contains 4 major steps: preparation, detection and analysis, containment, eradication and recovery, and post-incident activity. Let's look at them one by one. So in preparation, we actually establish a incident response plan. We define the roles and responsibilities of each member, and also each technique that is will be used in the detection phase. And we implement some proactive security measures. And in the detection and analysis phase, basically monitor the systems and the network traffic that is going through the infrastructure of a company or an organization. And then we analyze the logs, and then we utilize some tools to actually detect if there's any attacks happening in the organization. And once we have actually identified that there is an incident that is happening in an organization, we move on to the third step, that is containment, eradication, and recovery. In this step, we basically try to isolate the affected system so it does not propagate to the other systems in the infrastructure in the company. And we mitigate the impact, we remove it, then we try to restore the normal operations inside the company. And the last step, the post-incident activity, is conducting a thorough post-incident analysis, and we document what we learned so far, and we implement it in the future life cycles. And this life cycle actually works hand by hand. So after you go from preparation, then the detection and containment is like a recursive cycle. So you keep on detect the attack, and then you keep on removing it. And the post-incident activity, actually, after you have identified that you want to improve something, you implement it in your first step. And yeah, this is the conclusion for my presentation. So I have highlighted the issue that was faced by SOC operations. I have reviewed what the SOC is and different type of SOCs, and presented some stats that actually contribute to why outsourced SOCs are used by SMEs, and why we need to work on the incident response part of SMEs. And I also reviewed the incident response lifecycle. So any questions and suggestions? Thank you.
Thank you very much. Any questions or comments? And also, I think the venues monitor is now showing our face instead of the presentation material, I think. I think I have a question.
Yes.
Your presentation title contains work in progress. So what is your future plan of the research from now on?
So in the future, I would actually like to look at what other people have actually proposed for these solutions, and I've actually looked at few of them, that what techniques they have used to actually overcome this this issue, and try to see how we can actually come up with a better way to resolve this issue.
How about your university? Your university or your department is contract with SOC or something?
Oh, yes, actually, we are developing some sort of SOC as well that will actually deploy. We will give it to different departments that will actually help us to carry out our analysis and our implementation later on. So we are developing an in-house SOC solution.
I think there is 5 categories of SOC in your presentation. And I wonder how can I say? Maybe it is difficult to research, but I want to know the, how can I say, ratio of each SOC.
Ratio of each SOC that is utilized?
Yeah, because if there are not so many external SOC, then it is less effective to research about external SOC. For QC University, we have a contract with external SOC, but actually they are monitoring our next generation firewall, and actual incident response is done by internal IT team. So maybe it is co-managed because the SOC does not have direct access to our internal network. So I wonder if external SOC only is common practice or not. I wonder about that.
Yeah, actually, what happens with the most of the external SOCs, as I mentioned before, is that the SMEs don't really have the resources to actually employ to have a SOC in their own organization, and they don't have the experts to actually work tightly with an external SOC as well. Like the case that you mentioned, it's like you have some experts inside your organization that have the knowledge about their infrastructure and how they can change few things in the organization, and the external SOC is what actually tells you if there's an attack. So in your case, you guys can work tightly together to actually come up with a solution. But what happens in a completely outsourced SOC solution is that they don't really have an expertise inside their organization that can actually work tightly with an outsourced SOC. So it's completely dependent on the outsourced SOC to actually respond to the issue as well. So we're trying to come up with a way of some sort of like an interactive way so that the SMEs that do not have much knowledge about the SOC operations can actually still help to mitigate the issues.
Okay, thank you very much for explanation. Any questions or comments? I want to change the venue monitor to show the presentation, not my face.
So, Ikrar, kindly you have done the survey of these type of works, or your lab is already the facility is available of SOC through input to output scenario. So, which type of currently your work is involved in the survey and you are doing, or in any real time applications you are doing?
Actually, right now we are actually developing. I'm in a process of developing the application itself, and also I'm simultaneously doing the survey by myself as well. So it's like going in parallel, basically the development phase of the SOC and also the survey for the issues with the SOC as well. Yeah.
So any specific target of intruder you are dealing, or your supervisor has assigned any specific types of attack you are dealing, or that's general attack scenario you are dealing?
So for now, the attacks that I have seen happening in some of the public facing services that we have here were mostly some sort of DDoS attacks, and also an attacks in attempt to deploy a bot in the public services. So they attempt to actually execute some sort of code so that they can actually have their bot actually deployed there. So that's what I'm seeing so far, and I'm planning to target mostly on DDoS attacks, and also in attempts to gain unauthorized access to the system. So that's what I'm trying to focus on.
Thank you. Thank you.
Can I ask a question, Mr. Amin?
Yes,
Yes, please.
go ahead.
Okay, I am from Bangladesh Research and Education Network. So can you suggest me, is there any definite framework or architecture for the external SOC? I mean the hardware, software, human resources. In terms of that, what we actually need to establish an external SOC so that we can provide these services to hundreds of universities that are there using our backbone to get internet and data services.
Okay, so if I understand it correctly, you're asking me if there is a service that you can provide, that you can employ in your organization, that can actually provide internet services to hundreds of universities in Bangladesh. Is that correct?
Not internet, SOC services, security
SOC
services.
or SOC services. So if you want to employ a SOC, you want to offer an external SOC from your organization yourself, you can look at some open source SOC services that are available. One of them is Security Onion. So you can have a distributed deployment of Security Onion where you have the centralized site in your organization, and you can deploy the sensors. They call it sensors. So sensors basically what collects the data from different organizations that you will deploy your service to. So you can actually have that in your organization. Yeah.
It is mainly the software that I will be.
Yeah. So
public-
actually, you need to have a hardware-based solution. So in your organization, you can set it up in a VM. That's no issue. But when you deploy it in another location outside, you might have to either buy a mini PC or have a communication with the organization and ask them to set up a dedicated PC for you to actually monitor the traffic and also do the processing inside the organization. And then the alerts that will be generated will be sent back to your organization, where you will look at them and then do some threat hunting and then tell them if there's any incident. So it's mix of a hardware and software.
Okay, and in terms of human resources, what type of technical expertise?
I would say if someone with the knowledge of Linux networking, and that is required to set up the SOC. And if you want to employ someone who can actually proactively look at the threats, then you need to employ someone who has knowledge in SOC analysis. So you need to look at the logs and the alerts, and they can actually create some rules that actually helps them to connect some dots and see that, okay, if something is coming in and out, so there are some things happening. So mostly SOC analysts and someone who has knowledge in networking and Linux and distributed systems.
Okay, thank you very much.
You're welcome. You're welcome.
Thank you very much. Yes. Another one?
Just add something to what
Yes.
Ikrar has mentioned. So what Ikrar mentioned is more on outsourced SOC, but the question was actually coming from BDRAN itself, meaning they control the network. In this case, they can actually do it like what ISPs are doing. You don't have to deploy a hardware solution on the client network or the universities. You can tap directly in your data center or wherever the traffic converges, and then filter the traffic there. The only drawback is that you will see what's happening from the network, but you won't be able to say which machine if it is not mapped to the public IP directly. Just wanted to highlight that. Thank you.
Thank you, Doctor.
Okay, thank you very much. I think it's time to proceed to the next presentation. Thank you, Ikura. I'm sorry, I can't explain. So the next presentation is by Dr. Safat San. Are you here? Could you please prepare for your presentation? He is elected as a fellowship of this APAN meeting, and he'll present about cybersecurity challenge in the fourth industrial revolution comprehensive analysis. Please go ahead. Oh. Feel prepared. Okay.
Good morning.
Yes.
Honorable session chair, the researcher, distinguished guest, fellow colleagues. Good morning. So my topics is cybersecurity challenges in the fourth industrial revolutions, a comprehensive analysis. I'm the Shafai Hussain, head Department of CSE University. So at the beginning of this presentation, so we are all into the era of fourth industrial revolution. Already we have entered. So in this fourth industrial revolution's time, with the peoples having different components known as Industry 4, 4I are characterized with the innovative technologies such as mobile phone, social media, cloud, Internet of Things, AI, machine learnings, and all this together. And it is not a single technology. It's a complex and connected components that changes our lives with the critical aspects of 4IR, and the organization must adopt effective security measures to protect their systems and data. Here, the 4IR involves in a hyper-connected, since the devices, individual devices are actually working in different components. When they are connected, they actually deals with different problems in their own respective area. The fourth industrial revolution involves the dealing with the massive data volumes, designing human-machine interactive systems, and enhancing connectivity between the digital and physical worlds. Let me show you this is a historical background. For Industry 1, it begins in 1780 with the mechanizing of the productions. Industry 2, the manufacturing of large quantities of standardized product things in electricity, based on electricity in 1900. Then Industry 3, rise on the machines, the computers in 1970. Industry 4, with the combinations of IT operating systems through digital transformation, advance of the IoT. So here is an idea for the 4, and later on I show you how we can move towards from the 4 to the 5s. In Industry 4, see the industry of IoT. IoT, Internet of Things. I'm talking about focusing on industrial Internet of Things, because the industry here at this moment, they move towards the automations for the large amount of productions, and with the shortest periods of times, the rise on the machines. Here, the smart cities, heavy machineries, transportations, connected with the phone, TV, portable appliances. Things are very smaller in size. And home monitorings, home appliances, our home all automated through the smart network. And see this diagram, the smart network, all are connected with a single wing. Industry 4, what are the major components? Robotics, big data, cloud technology, machine learning, cybersecurity, integrations, automations, data, and IoT, Internet of Things. And I'm focusing on the industry IoT enabled technologies. 4IR cybersecurity issues. So since at the beginning I told that this is the hyper-connected systems, I can give you examples like, for examples, say in agriculture, land, in the soil, I'm taking this using a sensors, the soil moistures, and then collecting those data into the cloud. And after that, using artificial intelligence and machine learning, I'm predicting that whether these crops is suitable for this land, or the weather forecasting, depending on that, what are the soil moistures, fertilizers, and other things are given. See, these 3 components are in 3 different areas. Moistures, these sensors are in the land, and the data I'm actually sending to the clouds. And after that, I'm predicting the data through the machine learnings and predicting what are the agricultural crops, how we can improve the fertilizations and improve the qualitative production of the crops. Three things are three different areas. Data breaches may be happening anywhere. And eventually, all the data are in the cloud. In the cloud sectors, we may have provide the securities in the cloud. But thing is that if the sensors is not providing the proper data, or can we predict the actual predictions from the machine learning? No, we cannot. Since the three components in three different areas, all the components individually need to provide the securities. And since machines, software, hardware, cloud, these are integrations. So three integrations points in neutrally, we need to provide security, and combination efforts need to be provided. And here, the key points of the cyber threats, such as SQL injections, because the database is in the clouds, and cross-site scriptings can allow attackers to create, read, and updates, modify, delete. And modification and deletes can happen in any of the part of this complete framework. The 4IR involves dealing with the massive data volumes, as I told before, designing with the human-machines interactive systems, and enhancing connectivity between the digital and physical worlds. I'm not reading all these things. The key points from here in IoT includes the lack of security and privacy, vulnerable web interfaces, default weak and hard-coded credentials, malware or ransomware attacks, DDoS attacks, MITM attacks, phishing, social engineering attacks, physical attacks, data breaches, and theft and inside threats. These are the initial introductions for the IoT that includes challenges in the 4IR. Interoperability of Industry 4 devices, platform, and framework. I gave you an example that each of the components need to be provided the security separately. The hardware, the software, cloud, three things. Technical constraints for the smart manufacturing, lack of security design approach in the developing of Industry 4, complexity of Industry 4 system, and need to be holistic security approach. The combinator and efforts. It's difficult to ensure security in legacy systems and infrastructure, and need to for privacy and data protection to the context of Industry 4 and the IoT. Suggestion for the possible solution to address the cyber threats. Implementation is strong authentication and access control in every part, for the beginning to the end. Because the data's volumes comes, and then we are able to provide the appropriate technology for the artificial intelligence and the machine learning approaches. Regularly update the patching of IoT devices systems to address known vulnerabilities, because the new attacks will happen time to time, and need to update it with the using encryption to protect sensitive data transmitted over the IoT networks. Implementing instructions, intrusion detection and prevention system to detect and block malicious traffic. Conducting regular security audits and risk assessment to identify the address of potential vulnerabilities. And here is a point of the research approaches. Collaboration approach of research is required. Developing and implementing industry-specific security standards, agriculture field or the high volume machineries, equipments, industry, garments as well. So in the past, the garments, when the third industrial revolution time, we need high volumes of machineries. Today, the garments industry mostly followed this kind of mechanical devices, where the small amount of places, and they can produce large amount of production of garments, equipments, shirts and others within the short periods of time. And this shirt, how they produce the shirt accurately, how a human's measurements they take, because it was a predefined human, and they produce using the machines. Like Chinese machines are very modernized, and then they can produce a huge in a short period of times. Developing and implementing the industry-specific security standard and guidelines to ensure consistency where there is some legal issues as well. Garments or agricultures and high equipments, shipments or machineries, individual domain have individual legal works is required to ensure it. At this moment, so far we have seen, we have plenty of work can be done from forwards to fourth industry to fifth positions. But before going to that, if we don't have the legal issues, so what are the law and orders issues you can attack some of the peoples that who made it? Recommendation contribution to enhance the industry for cybersecurity, raise awareness, provide guidance on how to implement security by design approaches, promote the adoption of best practices standard of industry 4, facilitate the collaboration and information sharing among different stakeholders. Every stakeholder is important here. Academy, industry collaborations, the researcher, the expertise, including industry, academia, public authorities, humans, because a normal general people who use these IoT devices at home for home automation is also important. Otherwise, our home equipments like microwave oven, ASIS machines, these are all under the one network that can be breaches at any time. And though hardware is not a problem, but software can control the hardware. They can enter into any time, hackers. Encourage the adoption of holistic and continuous approach to industry 4 security, which takes into account the dynamic nature of the system and need to be regular updates and monitoring. Industry Internet of Things solutions, connected sensors to make real-time improvements to manufacturing, productivity and product quality. As I mentioned, this industry 4 enhances the quality, quantity, and cost as well. Reduces costs. IoT concept is supported by internet globalizations, openness, interoperability, and socializations. IoT is only one of the major components assisting industry 4 to reach its goal. Additionally, mentions some of the most promising future applications like edge computings, AI integrations, enhanced security measures, standardization and interoperability, 5G, yes, 4G moving, we're in the area of 4.5G, and connectivity with the advancement digital twins of simulations, sustainability and energy efficiency, solar energy, advanced analytics, and predictive maintenance. And all this is integrated approaches that need to be combined with the IoT solutions. Several challenges associated with the implementing IoT, including a lack of proper device maintenance, as I mentioned, the hardware and software integrations with the cloud, failure to ensure secure network services or data confidentiality. The NRAN worldwide, they can provide some guidelines so that different countries' research and education networks, somewhere have the capability to give the service of the cloud and can a different organization can have, because you can put our trust over there that they are the actually one of the stakeholders provide the secure service. Not all are actually capable enough to produce this kind of proper security measures. To address these challenges, companies can take several steps, such as investing in proper device maintenance and security measures, implementing individual access control policies, and developing solutions for machine errors. And the humans, most important, industry 4 can reduce jobs. Yes, that is one of the globalization point and threats. Instead of that, I'm pretty much optimistic. Who will operate the hardware? Who will operate the cloud? And those things are automation, but the maintenance work done by human. The applications made by human. The next generation is coming, 5G. And fifth industrial revolutions. Who will produce these applications? Human. Huge peoples required. In Bangladesh, I'm from Bangladesh, government predicts that within next 2 years, near about 10,000 to 20,000 cybersecurity experts is required. This is raw data. Real fact is more. What about the worldwide? In every aspect, as I mentioned, the different components of 4IR, cybersecurity challenges required in every steps, and we should be ready about it for the next. Overall, addressing the challenges associated with implementing the IoT requires a comprehensive approach that involves investing in the right technologies, developing proper policies and procedures, and ensures the employees are properly trained and aware of the potential risks and benefits of IoT. Potential future directions. Edge computing, we not yet started, will we start? AI integrations, enhanced security measures, standardization and interoperability, and RANs can provide us the proper guidelines from the universal worldwide, and then the country zonal in different parts may changes in different points. Advanced analytics and predictive maintenance can help companies identify trends, predict failure of equipments, and schedule maintenance, thereby reduce downtime and maintenance cost. See, here I have mentioned the maintenance and also some downtime. As I told you that in the garments industry, so everything is working in a scenario that our sensors, our hardware, our machineries, clouds, our AI software, everything working nicely. Sometimes it may happen that your sensor may die. You know, it's a hardware and electrical equipments. It may happen sometimes due to hardware failures and errors. So even yesterday, I was in a hotel, and sometimes I have that card that using that card, I have to enter into the hotel room for entering lights and others. It's not working. I cannot enter my room. It's a hardware problem. So things are totally combination, IoT. But for a simple component, that is a card, it may happen since it is a hardware and accessibility, errors, it cannot work, and they have to replace it to others. So this is also a problem. In every components, that is the security measures and problems we need to be ready for the advancement. Yes, the increasing number of connected devices. Here, all are connected through the laptops, phones, smartwatches. Time comes where your ACs, monitors, microwave ovens. So we need more IPs. All the necessary household or the, this is a very smart golf face hotel, legacy of near about 155 years, more than. So here we need to connect all the things in a single phase so that I can monitor, I can control, I can access. In that case, the connected devices are increasing. So need to monitor each and every components in such a way through automated process. Otherwise, manual process, impossible. Connected devices are increasing, and also the convergence of IT and operating systems, AI and machine learning, lack of skilled and cybersecurity professionals, the broad nature of threats. The cyber attacks can originate from anywhere in the world, making it difficult for an organization to track and respond to them. Since I told you that every components we may, while we are able to Hello. Yes, problem. Difficult for organizations to track and respond to them.
Excuse me. Can you hear me? It seems that the mic battery is depleted, so could you please replace the mic?
Hello.
Yes, okay.
Okay, technical problem.
Yeah, thank you.
Yes. My presentation is based on that. The hardware, software integration, everything. And during my presentation, a hardware problem occurs. And the manual, the human comes and then replies. So once upon a time, since I told you that lots of components, each time they are connected with it, it's not possible every time to manually correct it. Some we can monitor, and we need to find out some automation system to make necessary corrections for the devices as well. Anyways, we'll proceed to next, the developing and implementation strong cybersecurity standards and regulations, investing in research and development of new cybersecurity technology. And here lots of scopes, because every components need to have a combinational research activities, providing training and education to cybersecurity professionals, academia, experts, and new generations, collaborating with other organizations to share information and best practices. These are the key cybersecurity challenges in 4IR. Yes, at the beginning, I show you the history, and this is future. The end of 18th century, Industry 1 begins, the steam engine. Then 20th century, beginning with the Industry 3 based on the computer, 4 digital process, and the 5 Industry 4 co-worker. See who will be our colleague in Industry 4. I don't know whether we alive on during that time. Our colleagues are human, all human, right? But Industry 5, when it's beginning, our co-working, you see the machines and the human, they work together. Rise of the machines. The humans will be replaced in the 5. This is 2020. This is 2023, not very far. Here, the complexity 4IR to 5IR and beyond. Here is a summary from the Industry 1, 2, 3, 4. I'm just putting the right side of the diagram. The Smart Manufacturing System, SMS, for cloud manufacturing, cyber physical manufacturing with a circular economy manufacture. 4IR in the 21st century based on IoT, cyber physical system, digital platform, PSS networks. And upcoming, the 5IR with the mass customization, cooperation between the man and machine, cyber physical cognitive systems, sustainable system, human-centric system, resilient systems for the machines, robots, and human. Important points, cybersecurity challenge in the 4IR, like increasing number of connected devices. There is a more concern about it. This microphone will be connected in the next session, hopefully. The convergence of IoT and OT systems, the use of AI and machine learning, lack of skilled cybersecurity professionals. Yes, there's a lot of scope and opportunities in this area. Global nature of threat, increasing sophistication of cyber attacks, increasing impact of cyber attacks, need for a holistic approach of cybersecurity, because it is a very big areas to convergence. Importance of the collaborations and continuous improvement. That is idea for the future steps. Since we are staying in 4IR, we need to move towards the 5IR. Here are some of the skills that will be in demand for cybersecurity jobs in the 4IR. Security analysis and investigations. Yes, huge manpower expertise is required in that area. A security engineer, security operations, security awareness and training, risk management, and the compliance with devices, software, hardware, and integrations of all. Summarize all these things together. Here is the end of presentations. Thank you.
Thank you very much. Are there any questions or comments from the floor? I think it's a bit difficult to comment because the topic is very broad and many things you talked. But are there any specific topic you are especially
I have one
interested
question.
in? Oh, okay. So please go ahead.
So IoT is already there. Is there any framework that all these IoTs are automatically controlled through a central automation process? And if it is there, is it an open system or is it proprietary? Because the IoT devices, they are coming from many different companies. And if I want to make a centralized automation control system, then I need a standard protocol to communicate with all such devices. So is there any such standard protocols that is there in real life or practical IoT industry?
Yes, very good question, sir. IoT, as you mentioned in your questions, is IoT devices comes from different areas with their own standards, and we need to collaborate with them, sharing with them to actually exchange data to implement our systems. Since it comes from starting from the sensor, it comes from the sensor companies in different, and then we need to integrate with the software, the Arduino or others devices. So in that case, the sharing, it has its own protocol. In my presentation, I have mentioned the standardizations because when there is a centralized system, and this centralized system need to monitor from a single place, then without these standardizations, we cannot able to do that. So from the policymakers also come forward to that, because since then, today, all are open source. And the proprietary in such a sense that the device or sensors maker, the manufacturer, they have their own protocols. We need to, while they exchange, we need to cross some measurements to share our data. So in that case, facing some difficulties. Sometimes during implementation, when I check, I cannot read the data from the components, because without their policy, it will not work. When there is a cross, there is a problems for the hardware software. So in that case, it's a combinational effort. The policymaker need to provide a guideline so that every components can share and connected with each other, so that a centralized possibilities, centralized system can be possible. And at this moment, maximum is open source.
Thank you.
Thank you, sir.
Any questions or comments? Okay, I think it is time to close the first session. Thank you very much for your presentation, Mr. Hussein, and also please give a big hand to all the presenter and the people who joined the discussion. And so we have a coffee break, 30-minute break, and we will resume the session from 11 a.m. local time. So please come to the room again after 25 minutes. Thank you very much.
Thank you.